Good evening. This is Michael Ruffin's Project 2 video for Mechatronics, which basically covers rotation matrices and how to input them into the Python program to help multiply and calculate them. So a rotation matrix is basically a tool we use to identify and define coordinates within a frame in respect to coordinates of another frame, because within a robotic manipulator there are multiple joints and links, and each joint and link has its own frame of coordinates. So we basically use a rotation matrix to figure out the set of coordinates from one frame with respect to the previous frame. But when multiplying these matrices together, we have to do it in chronological order, because frame 1 can move frame 2, but frame 2 can't move frame 1. So in order to figure out the overall matrix of the entire system, so to go from the base to the end effector, you have to calculate each matrix in numerical order. So calculating these matrices by hand is tedious work, and it takes a long time, especially depending on how many frames of coordinates there are. So to speed up that process, basically this project just shows us how to input these matrices into Python to calculate the overall matrix from beginning to end. So up top, we had to import numpy as np, just because it's a function we'll be using throughout the project. So it makes it easier to type, which you can see right below that, print np.py, and it just prints the values of pi. And so below that, we have the first matrix, which is just a regular matrix just to make sure we're typing it in correctly. And then below that, we printed it in the way that it should be, it should be formatted, which is a 3x3 form. So then on this side, same thing, import numpy as np. And then we have theta 1 and 2, both identified starting in 0 degrees. Below that, we have the two equations to put those values in radians. And so below that, we have the two matrices that we're multiplying together, which is R0 to 1 and R1 to 2. And you can see those matrices typed out with the cosine and sine placed as needed. And then below that, we have the final product matrix, which is 0 to 2. And to get 0 to 2, you have to multiply 0 to 1 and 1 to 2 together. So 0 to 2 is just the dot product of those two matrices. And then we print 0 to 2. So this first matrix with the ones and zeros is for when both theta 1 and 2 are 0. So then I changed theta 1 to 90 degrees, and we got this matrix here. This one, the one at the top. And then I changed theta 2 to 90, and I put theta 1 back to 0. And then we got the matrix below, which is this one on top. And then just started playing around with it, changing some of the values and getting different matrices. So I'll just show you. So here I'll do 45. And I'll do this one at 15. I'll run it, save it, and then gives us the new product matrix. Now I'll change it one more time. So I'll do 5 for theta 1 and 75 for theta 2. And we run it, save it, and it gives us the new product matrix. So this code is just giving us the product matrix of these two matrices here using the theta 1 and theta 2 values that I input. And that is project 2.